So hello everyone, we are back with another problem. This time, the problem is about pulleys, and we are given a load A that is being pulled with the help of two inextensible strings that pass over two fixed pulleys as shown in the figure. At this instance, one of the pulleys is pulling the thread with the velocity u1 and another one is given the velocity u2. At this moment, the threads of the pulleys are making an angle theta between them, and we have to find the speed of this load A. Okay, pause the video, give it a fair attempt, and whenever you're ready, we'll start with the solution. Welcome back. Let's look at the solution now. We have a block A that is having a velocity u2 along this thread and a velocity u1 along the another one. These are separated by an angle theta. For our convenience, let's just rotate these vectors. We'll obtain u2 in a horizontal direction, and subsequently the velocity vector u1 is at an angle theta. This is u1 and this is u2. Now let us mark these axes. Let us mark an x-axis along the direction of u2 and a y-axis perpendicular to it. That means that the motion along this thread will be considered to be in positive x direction, and perpendicular to it would be our positive y direction. Let us assume that the final velocity vector, the resultant velocity vector, has components vx and vy along these axes. Let us go back to the basics of our vectors, and we'll notice that the velocity vector u2 should be equal to the velocity vector vx because they are distinct velocities in the same direction. So we can write vx is equal to u2. Right, that makes sense because the velocity in the direction x should be equal to the velocity along this thread. Similarly, this is 90 minus theta, right? So notice that the resultant u1 must be formed by contributions from vy and vx. Let's take components in that direction and we'll find vy sine theta plus vx cos theta to be our resultant vector u1. Now, to find the speed, that is v, we need to take vector magnitude of these two components. We know that vx is also equal to u2. Thus, vy is equal to u1 minus u2 cos theta upon sine theta. By putting these values here, we'll see that vx square is u2 square plus vy square is u1 minus u2 cos theta upon sine theta, the whole square. By simplifying this, we'll see that our resultant would equate to u2 square sine square theta plus u1 square plus u2 squared cos square theta minus 2 u1 u2 cos theta upon sine squared theta. Upon simplifying this, we'll see that the coefficients of u2 square will become 1, and our final answer would be v equals u1 square plus u2 squared minus 2 u1 u2 cos theta under root divided by sine theta. Thank you.